Hi everyone, the question is define g of x is equal to integral minus 3 to 3 f of x minus y f of y dy for all real x, where f of t is equal to 1 for t greater than equal to 0 less than equal to 1 and it is 0 elsewhere. Then four options are there. We have to comment upon continuity and differentiability with respect to this function g of x. So here given that f of t is 1 for t varying between 0 closed to 1 closed and elsewhere it is 0, so I can say g of x is, so I can put the limit to be 0 to 1 only, elsewhere f of y would anyway be 0 and 0 multiplied by anything is 0. So 0 to 1 integral f of x minus y, and in this interval f of y is 1, elsewhere f of y is 0, so that those intervals we have anyway removed, because ultimately they would be giving 0, and here f of y would be 1 throughout this interval 0 to 1 as per the definition of f of t. So you get dy. Now let me put x minus y as, let's say let me put it as t, if, since t is used here anyway, it doesn't matter much. So you can say what? You can say minus dy is equal to dt. Yeah, so here g of x is essentially what? It is essentially you have f of t minus of dt, dy is minus of dt, yeah, and as you put y to be 0, you get t to be x, and as you put y to be 1, you get t to be x minus 1. So essentially it is integral x minus 1 to x f of t dt. Yeah. So here you can say when x is when x is less than equal to 0, what about g of x? The lower limit would be less than equal to minus 1 and the upper limit would be less than equal to 0, and in this entire interval f of t is 0, so the value of g of x is 0. When x is between 0 and 1, the lower limit is essentially between minus 1 and 0, and the upper limit is between 0 and 1. So ultimately what you would have is since f of t is positive only in this interval 0 close to 1 closed, it becomes integral 0 to x ft dt, and in this interval given that x is less than equal to 1, f of t is 1 only, so 1 dt, and what you get is x. When x is between you may say 1 and 2, the lower limit is between 0 and 1 and the upper limit is greater than equal to 1. So ultimately again, since f of t is 1 in this interval 0 to 1 only and otherwise it is 0, you can say it is integral x minus 1 to 0, x minus 1 to 1, x minus 1 to 1 integration 1 dt, because in this entire interval f of t is 1, because x minus 1 is between 0 and 1 and upper limit you are taking as 1. So this essentially gives us what? This essentially gives us you get 1 minus x minus 1, so you get it to be 2 minus x, simple integration. And for x greater than equal to 2, the lower limit is greater than equal to 1 and the upper limit is greater than equal to 2. So again in this entire interval f of t would be 0 and g of x would turn out to be 0, because this integral value will turn out to be 0 because integrand is 0 throughout. So here if you plot the graph of g of x, so it turns out to be for x less than equal to 0, g of x is 0. For x between 0 and 1, it is x. For x between 1 and 2, it is 2 minus x, and for x greater than equal to 2, it is this. So 0, 1, 2. So here you can clearly see that g of x is continuous everywhere, but is having sharp corners or kink points, that means non-differentiable points at x equal to 0, at x equal to 1 and at x equal to 2. D is the answer. Thanks for listening.